Hello everyone, my name is Patrycja Wegrzynowicz and today I'm gonna tell you about session management and secure authentication in Java EE. Okay, I see that you are pretty tired, so I will have a couple of demos to wake you up. But first, briefly about myself. I've been doing professional software development for over 15 years. I've always been close to code and I still am active developer. And I must say, I love it. Most recently, I founded a company, Yonita. It's a startup when we work on automated tools to detect software defects like security vulnerabilities, like performance issues, like database anti-patterns. So basically, security vulnerabilities are my daily job. What am I gonna talk today? First, a brief introduction to security problems, HTTP and session concept. And the key part of today's talk includes 4 demos that illustrate how to hijack sessions, how to use XSLs to steal user session IDs, or how to exploit cross-site request forgery to use the session without the permission of a user. For last 2 decades, web technologies have experienced significant growth. The number, the size, and complexity of applications have increased substantially. Unsurprisingly, many new techniques to attack IT systems have been developed as well. A lot of security vulnerabilities have been discovered last years. 2014 and 2015 have been like black years for IT industry. Heartbleed, who of you heard of Heartbleed in OpenSSL? Yes, that's a serious vulnerability in OpenSSL library. Shell shock, anyone heard of that? In Bash, another serious vulnerability. This year started with logjam, with TSL and SSL key exchange. It turned out it's unsecure and easy to exploit. So there's no question that security is important in today's world. So let's go back to the web. HTTP is the foundation of communication in the World Wide Web. It's a stateless protocol. What does it mean, stateless? It means that each request is processed independently. And as we think of web applications, it's pretty obvious that we need statefulness. We must keep track of the user authentication and keep track of his interaction just in order to display personalized data, like to check permission, like to keep track of shopping basket, and so on. So how can we achieve that? That's a place when session concept comes in handy. A web session identifies interactions with one user. The implementation is pretty simple. We need to associate a unique identifier with each request coming from the same user. In Java EE, this identifier is named by default JSession ID and is implemented as a cookie or a parameter. So everything works great. So what's the problem? Here's the problem. Broken authentication and session management is number 2 on the list of the top 10 security risks according to OWASP. OWASP stands for Open Web Application Security Project. It's a non-for-profit organization which aims at increasing security awareness among developers. So every 2 or 3 years, OWASP publishes the list of top 10 security vulnerabilities in web application, and it turns out that authentication and session management cause a lot of troubles to software developers. The problem is that we, as developers, rely on the platform. We rely on session ID as a single means to identify user, and we don't protect it carefully enough. We think, usually, that the platform will do that for us. So basically, I thought the same. The first time I had some interaction with security teams, it was like over 10 years ago, and it turned out that in my application I did all possible mistakes when it comes to session management. And my reaction was, at first, before I found out what happened, my reaction was, come on, Java EE server will do that for me. I don't need to care for that. Well, we still need to care for that. So there are 3 primary types of session attacks. The first one is session theft. So the hackers can steal the session ID and can use it. The second one is session fixation. It basically means that hacker can open the session, can leave a computer open, browser open, and the web page open for another user. The user comes, logins, and uses the same session ID as the one generated for the hacker. And the third typical attack on session is session prediction. So the hacker can predict how the server generates session IDs and can use one of those predicted IDs to get his hands on user's session. So the third one does not relate to the average Java application server, but still it can happen. The first demo. Is very simple, just to show you how easy it is to access session exposed in URL. Are you ready with your laptops, tablets, or cell phones? Are you ready? Raise your hands, please. Okay, great. Yes. No, it's not this one. That's this one. Oops. It seems I'm not connected to the internet. Wait a moment, please, and I will fix that. Yes, now it's better. Basically, I will use my Twitter account to post links. That's a simple application. I will log in with my credentials. Okay, I will post that link on my Twitter account. That's YonLabs. So that's important for you. And I will ask you, oops, something takes too long to post a link. Okay, let us wait a couple of seconds. So basically you see that the JSession ID is exposed in URL, and that's enough for you to access my session. So think about all those cases when you are in a public place, like coffee shop, like conference, like lectures, and you use your devices, and everyone can take a photo, right? And they can see your screen, and if session ID is exposed in URL, boom, that's done. Wait a moment, I will try. Oops, something's, it seems that, that's a huge problem because all my demos are based on the internet. There is another network, Wi-Fi, JavaDay.org. Do you have password for that? Yeah. Because without internet connection, I can't do any demo. Okay, wait a moment. I will use my cell phone, and I hope it will work better. No, it doesn't work. Okay, wait a moment, please.
Try connecting to Java.org. Password is from 1 to 8.
Okay. I will try another network. And we'll see how it works. And how is that for you? Do you have Wi-Fi connection, and is it good? No, you don't have it. That's really bad. Okay, I can do them on my network or the other one if I connect. But it doesn't want to connect. Okay, without connection, I can't do much. So let me wait a minute or so. Okay, I'm connecting to my own cell phone hotspot. Okay, it should work, hopefully. Oh my God. No, I don't have connector. Okay. Because it works really poorly. And I went through all my demos just before the session to make sure whether they work, and they worked, just to say to you. And it's always the answer from IT department. It works on my side, right? Okay, so it works here. I will try to log in once again. Okay. So once again, I will try to post to Twitter. Hopefully, any of you have your own connection, so we can connect to the internet and we can cooperate to make it working together. Yes, okay. The first success. Please applaud and wish me good luck. Thank you very much. Okay, so now I will click on my secret page and I will wait for you to click that as well. So please use that link that I posted on Twitter and try to, yes, there was some other connection or yes, that was other. You see? My OS version is 10.11, it's the last Mac OS, and there is Mac OS 9, so I guess it's Mavericks. Who connected? Please raise your hand. Thank you so much for your cooperation and that you have, lucky you that you have connection. Okay, so basically you see how easy it is to access other user sessions once you get the identifier. That's all you need. So probably the problem was that the session ID was exposed in URL, right? So how can we avoid session ID in URL? By default, our configuration in Java application is that our application will use cookies, and then if the cookies are turned off on the user side, it will fall back for URL rewriting, so the session ID in URL. Just to embrace all users, also those who have disabled cookie support in the process. So how can we disable URL rewriting in an app server? That can be app server specific. And since Java EE6, we can use tracking mode in web.xml just to disable that. So that's a simple configuration in your web.xml supported from Java EE6 and Servlet 3.0. Tracking mode set to cookies explicitly allows only for cookie managed session IDs. So does it solve our problems? No, because we can find out cookies in other means, like by network monitoring or packet sniffing, and then we can use cookies very easily. Like we can use browser plugins and add-ons like Cookie Manager for Firefox. We can use intercepting proxy to set up new session ID in a cookie. The example of such a proxy is OWASP ZAP. Or we are, after all, developers, so do it yourself and write your own code that connects to HTTP and sends your own cookie. So I will show you another demo. You've hijacked my session, and now I will hijack yours. I will post a link on Twitter again. Very similar application. You can log in with any non-empty username and non-empty password. I will monitor network traffic by using TCP dump on the server side, and I will hijack one of your sessions using a cookie manager. So let me start by running TCP dump. My application is hosted at Amazon Cloud, and it's based on Glassfish, and it's a simple Linux server, so TCP dump is out of the box, and it's a packet sniffing tool. Okay, no network traffic at the moment. Okay. I will post this link on Twitter. And I will wait until one of you will use this. Okay, someone is trying to do that. Okay, we've got, we are waiting for a successful login. Anyone here who managed to log in? Please raise your hands. Okay, so I'm okay. I will use this session ID. Take a look at how I'm doing that. I will just go to that page. I will log as myself. And then I will use cookie manager to replace the cookie. Yes? Wait a moment. It seems I can't make it bigger, at least when it comes to cookie manager. So I'm sorry for that. Okay, this one is for session cookie. Just replacing the value. Wait a moment. Okay, I managed to save it. Okay, who is QWE? Yes, I've got you. I've hijacked your session. So again, it's not a rocket science, right? So it's relatively simple to hijack sessions when we get session ID. So basically the problem is that hackers can get their hands on session IDs pretty easily. So how to avoid session exposure during transport? Any answer here? Yes! That's elementary, my dear Watson. Encrypt and use HTTPS. Exactly. So that's our answer. So how to configure that on the server side? We can use web.xml and to guarantee that our application will be always available over secure channel. So we can configure transport guarantee and set it to confidential in web.xml. Another thing is to configure secure flag for our cookies. What does it mean? Secure flag means that cookies will not be sent over unsecure channels. That's very important. Why? Because sometimes it happens that we serve the content over HTTPS and HTTP. So we mix that. For example, we serve static content over HTTP, just images, JavaScripts, etc., just to speed up performance and make our application more scalable. And in that case, the browser would send cookie over those unsecure channels as well. So we need that additional flag secure for cookie to instruct browsers not to send cookies over unsecure channels. So basically, how can we expose cookie? Obviously during transport. So we've managed to address that by using HTTPS and secure flag for our cookies. We can expose cookies on the client side. For example, XSS, cross-site scripting, is often used to steal users' session IDs. There are a lot of attacks on the browser or OS level to get access to the user's data. But that's not what we address during today's talk. And we can also think about the server side. Think about your logs, think about session replication. How many of you logs your session IDs? Yeah, there are a few of you. So that's another possible place where session IDs can leak. Obviously, the probability is lower in that case because it happens on the server machine, so it's like a protected environment with a limited access, but still, think about insiders, etc. So it's better to avoid that. So now I will show you how to steal a session if secure transport is used. How can we do that? We will attack client. So to make it happen, I need 3 pieces of code working together. It's JavaScript code to steal a cookie. It's a servlet to lock down stolen cookies. And obviously, I need vulnerable application to be exploited via injected JavaScript code. Session grabbed by XSS. First, I will open a sort of application that serves for gathering, collecting opinions on a server. On a service, so everyone can access it and write his or her opinion about the service. I will log into the vulnerable application. I will write malicious opinion, and then I will post a link for you. You can log, you can view opinion, and silently your cookie will be sent to my server. Okay, so that's another application. This is a huge text I will to write my opinion. Obviously, it's a wonderful service. And now take a look at malicious code. It's very simple. This is a link to my servlet, hacker's servlet, which will just log down stolen cookies. Do you see that? Or do you need it bigger? Oops, now you can't see that. So still is just a URL, and we access in JavaScript cookie element. Do you need it bigger? Okay, wait a moment. Yes. Here I can make it. I can make it bigger. Yes, that's true. Okay. Now it's more readable. Thank you. Okay, so that's pretty simple, right? We just construct a URL with a cookie inside it, and we load it via image source. Why do we load it that way? Just to bypass the same origin policy in the browser, because browsers are not allowed to load links from other domain, just to avoid exploiting, but it's allowed in two cases: to load scripts and to load images, because those resources are often hosted from other servers, again, just to speed up our applications. So we exploit that feature of a browser, and we load the URL of a different server just to make sure that it's possible and to steal the cookie. Okay, so I will copy it to my opinion, and it's saved. I can see others' opinion, and it says it's awesome. You can't see that. And now I will ask you to log in and see these opinions. I will go to my server and I will observe the logs. So please log in, and then please access the page which displays the opinions. Anyone ready? Raise your hands, please. Oh, I see something coming in on my server. So now I will try to use one of your sessions just to hijack it. So again, I will use Cookie Manager. I will go to Firefox. I'm logged in as random user. I'm changing cookie for Yonita and XSS application. And then I'm logged as Dimitri. Who was that? Oh, thank you once again. So that was very helpful. So you see how that happened. That was very, very easy, even though we used secure channel. We used HTTPS. We can see how it looks like in the page source, because here we have only text opinion visible. We don't see the script, but it's there. It's there. View page source. and you have that script hidden in the page source. As I said, we used only one trick. We used image source to load foreign URL and to bypass the same origin policy in browsers. How can we avoid that? In our web.xml, we should configure HTTP only flag for our cookies. Surprisingly, HTTP only flag was introduced by Internet Explorer, and now it's standard for most modern browsers. Unfortunately, it's not a part of HTTP protocol, so it's not in the spec, but still most modern browsers support it. And what does it mean? It means that cookies won't be available from JavaScript. So that XSS will be still possible, but hackers won't get their hands on our cookies. They will get like empty string. So that's why it's so important to use HTTP only flag. Briefly, I've told you already about session fixation, how it happens, because it's another form of attack on session. Basically, it's more like a social engineering and a sort of exploiting of behavior of the server side. When a hacker opens a web page of a system in a browser, usually new session is initialized on the server side, right? Hacker has access to the browser, can see cookies, so he can simply write down the session ID which was assigned to his session. Then he leaves the browser open, then user can come and log into the application, and the server uses previously initialized session. Usually server does not generate a new session, right? So then hacker can use the written down session to hijack the user's session and get access to everything. So how can we fix that? We should change the session ID after successful login. More generally, it should be done after any escalation of privileges. In Java EE7, Servlet 3.1 spec, you should use change session ID method in HTTP servlet request class. And in Java EE6, you could just invalidate the session and request a new session. Please keep in mind that if you have anything important in your session, that should be copied to the new session. So we need to copy any attribute which is important to our users to a new session in case of the second approach for Java EE6 or any lower. What are the best practices for secure session management in our application? First of all, random unpredictable session ID, at least 16 characters. So again, most modern Java application servers support that. Anyone here who uses Jetty in production? Raise your hands. You probably have a problem because Jetty uses pretty short session IDs. So that might be a problem, and it might be vulnerable to session prediction attacks. Then we should use secure transport and storage of session IDs. So cookies obviously preferred over URL rewriting. Cookie flags, secure and HTTP only, very important. Then we should consistently use HTTPS and we should serve static content from a different domain name then we serve the application itself. So we shouldn't mix HTTP and HTTPS under the same domain cookie path. And we need to keep in mind to don't use too broad cookie paths. What about session creation and destruction? Obviously, we should use new session ID after login. We should keep in mind that we should have a logout button and session timeouts. For critical application, it should be like 2 or 5 minutes max. For typical app, 15 or default 30 is good enough. Another thing, it was pretty easy to exploit our sessions because we didn't use any other mechanism to protect connection and to detect connection coming with a session ID. We relied only on session IDs. That's the default behavior of any application server. So we could use another approach. We could associate with a session some other headers of the first request, like IP or like user agent, and we could make like a fingerprint of a session and then check it with every next request, subsequent requests. If they don't match, something's going wrong, and we should invalidate the session and raise an alarm. Because most likely, hacker is trying to connect using the same session ID as the original user. For secure authentication, we can use declarative authentication or programmatic authentication. We should keep in mind that the spec does not force new session ID after login for declarative authentication. It depends on the server. It's sub-server specific. For example, Glassfish and most modern servers support changing session ID, but again, you need to verify that in your server. For programmatic authentication, we can use Java E7 with authenticate login and logout in HTTP server's request. That way we can implement more advanced flows and requirements like that session fingerprinting. And my choice would be programmatic authentication with session fingerprinting and declarative authorization, so web.xml and annotations, roles allowed, permit all, and deny all. And the last demo of the day, what if we can't steal a cookie? Well, we can still use it. I will show you how. We can exploit close-site request forgery to use the cookie without the knowledge of the original user. So I will log into application, and this is a simple application like a banking account. So my balance is 1666. I will post a link for you, just for you to log in. So please log in and let me know if you are ready. I will post another link that will contain the attack, and we'll see what happens if you click the suspicious page. There is a simple click me button, so please click the button. And I will go back to my, oops, I've lost my account. Okay, it's here. Oh, you see? Seamlessly, I got more more money transferred to my account. So what happened? Our suspicious page, the attack page, it has a hidden form. Oops. Okay, I will show you that in my IDE. Basically, it's a hidden form which is executed when you click the button, and it sends the request to the server. And what happens then? It sends the request to the original server, and every time with the request sent to the same domain name, the browser sends cookie. So basically, here you have that hidden form, and it has sent to field set to Patrycja, and here's the amount set to 666. So basically, it exploits the feature of a browser that with every request sent to the same domain name, sent to the same domain name, the cookie of the logged in user is sent. So transparently to the user, in the background, we send a hidden request with our pre-crafted, predefined requests, which caused the action on the server side. Basically, you need to be aware what you click on. That's how all the malware is spread, by phishing. If you receive any unknown emails and you go through emails in your browser, think what can happen. For example, you don't need to click on any button at all. Those malicious URLs could be hidden as images, because if you have your images in the browser turned on in your web client automatically loaded, then it could load a malicious URL and go to any malicious site, sending the logged in cookies. The conclusion is that you are never safe. For sure, you know the paradigm of continuous integration. Who uses continuous integration? Yeah, almost all of you. Often giving training on coding, good quality coding, how to program a good application. I'm talking about continuous refactoring, because we need to fix all the issues constantly. So now I would postulate continuous learning paradigm, because a fool with a tool is still a fool. We need to educate ourselves to become better developers and to implement and protect our applications carefully. So that's all. I hope that I've shown you a couple of tricks how to protect your application against some sort of attacks. Java EE has pretty good support, but we need to use it, and we need to use it smartly. Thank you.